Okay, so the question is, what is the order of increasing acidity of the following acids? There are 4 acids given. For the 2 acids the K value is given, and for the other 2 acids pK value is given. Now we know that if pKa value is low, the acid will be strong acid. Acid will be strong. So more lower the pK value, more stronger the acid. So we will convert the K values into pK values, and then we will compare all the 4 acids. The acid which will have the lowest pK value will be the strongest acid. So how to convert K into pK? So pKa is equals to minus log to the base 10 of Ka. Okay, so for chloroethanoic acid, K value is given, so the pK for this will be minus log to the base 10 of 1.3 multiplied by 10 to the power minus 3. So this comes out to be 2.88 pKa. This is the pK of chloroethanoic acid. In the same way for ethanoic acid, pK will be minus log to the base 10 1.7 into 10 to the power minus 5, and this comes out to be 4.76 or 4.77. So this is the pK of ethanoic acid. So if we see which one has the lowest pKa will be the strongest acid. So we saw that chloroethanoic acid is the strongest. And then higher to 2.88 is 3.3, so it will be less stronger will be hydrogen fluoride, and then ethanoic acid, and then hydrogen cyanide. So option is D option. So the correct option is D. Okay, so the question is, which has the strongest conjugate base? So which will have the strongest conjugate base? So a weak acid will have a strongest conjugate base. So weakest acid will have a strongest conjugate base, Weakest acid will have a strongest conjugate base. So out of these 4 acids, which is the weakest acid? So weakest acid will have highest pKa. So highest pKa will be there. Highest pKa. Highest pKa acid will be the weakest acid. So for 2 acids K value is given, and for 2 acids pK value is given. So we will convert all the K values into pK values. For HCOH, pKa will be minus log to the base 10 of Ka value. So this will come out to be 3.74. Now for HNO2 pKa will be minus log to the base 10 in the same way. 7.2 into 10 to the power minus 4, and it comes out to be 7.2 10 to the power minus 4 comes out to be 3.14. And for HCN, pK is already given 9.21, and for HiO3 pK is given 0.77. So which has the highest pK? HCN. HCN has the highest pK, so it is the weakest acid and it will have the strongest conjugate base. So the option is C. Correct option is C. Okay, so the question is pKb of HS negative is 7.08. What is its conjugate acid and what is the Ka value of the acid? So its conjugate acid will be formed by accepting a proton. So HS negative can accept a proton and it can form H2S. So this is the base and this will be its conjugate acid. So Kb is given. So pKb is given. pKb is 7.08. So we know that pKb plus pKa is equals to 14. So therefore pKa will be 14 minus 7.08, and this comes out to be 6.92. Now how to calculate Ka? So Ka will be 10 to the power minus pKa, that is this. So the correct option is A. Okay, so the question is what is the pOH of 0.1 mole per dm cube of acetic acid given that Ka of acetic acid is 1.74 into 10 to the power minus 5. So we need to find pOH. To find pOH, if we know pH, we can subtract that pH from 14, we get pOH. So to find pH, we need H plus ion concentration. So how can we find H plus ion concentration? We know that acetic acid dissociates into H plus ion and acetate ion. K is given to us, so we can write K expression, that is the dissociation constant or equilibrium constant for this reaction. CO negative concentration, H plus ion concentration, divide by acetic acid concentration. Now the concentration of acetic acid is given to us, initial concentration 0.1 mole dm cube. After it dissociated into H plus and acetate ion, the concentration of H plus ion will be equal to acetate ion, because 1 mole can give us 1 mole and 1 mole, but it is a weak acid, so it will not completely dissociate. But the concentration of H plus ion, this H plus ion and acetate ion will be same, because 1 mole and 1 mole are formed. So we say that the concentrations at equilibrium for H plus ion and acetate ion are equal. So we can consider that this numerator we can change to H plus ion square concentration. We can say that this is H plus ion square concentration divided by acetic acid molar concentration. Now since acetic acid is a weak acid, so the dissociation of acetic acid will be very small, so we can say that nearly this is equal to the initial concentration. So therefore K is given 1.74 into 10 to the power minus 5, and that will be equal to H plus ion concentration square divided by 0.1. So we have approximated that acetic acid dissociation is very small, so the equilibrium concentration of acetic acid will be same, nearly same as the initial concentration. And from this equation we can solve for H plus ion, which will be the square root of 0.1 multiplied by 1.74 into 10 to the power minus 5, and this comes out to be 0.001319, and then we can find the pH. pH is minus log to the base 10 of H plus ion concentration, that is 0.001319, and this comes out to be 2.88, and then we can find the pOH. pOH will be 14 minus 2.88, so it comes out to be 11.12. So pOH. So this is the answer. So option A. Okay, so the question is, a buffer is produced by mixing 20 cm cube of 0.1 mole per dm cube acetic acid with 0.1 mole per dm cube sodium hydroxide. What is the volume of sodium hydroxide required and the pH of the buffer? So we know that acetic acid can react with sodium hydroxide to give sodium acetate, CH3CONA, and water. And this is 1:1 ratio. 1 mole acetic acid react with 1 mole of sodium hydroxide to give 1 mole of sodium acetate. Here our buffer will be acetic acid with sodium acetate. So this is an acidic buffer. So acidic buffer means the pH will be less than 7, of course. Then the volume of acetic acid is given and the concentration is given, mole per dm cube. This is for acetic acid, CH3COOH, and we need to find the volume of sodium hydroxide, and the concentration of sodium hydroxide is given 0.10 mole per dm cube. So we need to have equal amount of acetic acid and sodium acetate in the solution. Since the concentration of sodium hydroxide and acetic acid given to us are same, 0.1 and 0.1, so in order to convert half of the acetic acid to sodium acetate, we would require only 10 cm cube of sodium hydroxide, so that half of the acetic acid will convert into sodium acetate and half of the acetic acid is left. So this will be the volume of sodium hydroxide required, and the pH will be less than 7. So the option is D option.